Just check this is working. I think this is working. Good evening, everybody. Welcome to the Bath Royal Literary and Scientific Institution. Glad you could all make it this evening. I'm James Hamilton. I'm the General Manager here at BRLSI. We are running a series of talks which are kind of an add-on to an exhibition that we've been running for the last, we're into our third year now. The exhibition is going to run from March the 1st to the 4th this year, and it's called Brilliantly Engineered. And it involves a lot of local engineering companies, and we run a weekend exhibition, and we run school workshops on Monday and Tuesday, where we get school groups in, and the James Dyson Foundation run a lot of kind of fun engineering tasks for the children to take part in. It's all free, and it's fun, and it's educational too, and it's the kind of thing we're trying to do more and more at the institution. So we thought this year it would be very nice to try and support the exhibition with some interesting talks in the run-up to the weekend that it happens. So really pleased tonight, to introduce you to Tim Minshall. Tim is an author, best known for his groundbreaking book, Life is Manufactured, of which we are going to hear a lot more tonight. So with a background in engineering and innovation management, Tim has dedicated over 2 decades to exploring the intersection of technology, manufacturing, and societal impact. He's held various academic and leadership positions, including serving as a professor at the University of Cambridge, where he inspires the next generation of innovators. Tim's insights have been featured in numerous publications, and he frequently speaks at conferences around the world, sharing his expertise on the future of manufacturing and sustainable practices. His work emphasizes the importance of creativity and collaboration in driving progress, making him a compelling voice in today's rapidly changing landscape. Tim has copies of his new book here, many copies here, and is very happy to sign copies, so please do stay on afterwards and have a chat with Tim, have a look through the book, and we can take your money for a book if you would like to buy one. No more from me, but Tim's going to come up to the front. Please join me in welcoming Tim Minshall.
Indeed. Thank you, James, and thank you very much for coming along this evening. I'm very, very pleased to be here. I have to do something a little bit strange now. For those online, I have to do this. Blue light flashes, and now this camera will follow me around. So I don't have to stand here. It'll actually, let me just check that's going to work. Very creepy. Right. I'm completely transfixed by this now, and hello to everybody online. So the reason I'm here is partly because of the book, but it's more about the message of the book that we're trying to share as widely as possible. And it's based on a very simple, but I think important premise. And it's this: every single thing you can see in this room now, apart from people. If there were any rocks, there aren't. Are there no plants? There are no plants. There are no animals other than humans. Everything has been manufactured. Someone, somewhere, had to design it and go, right, that thing is needed, and they've worked out what materials are needed and done some processing of those materials, and then said, right, I need to assemble it into a product, I need to get that product to where it's needed, and then it's used in some way. Every single thing. I just found it's a bit like, for those of you who've read The Hitchhiker's Guide to the Galaxy and the Total Perspective Vortex. Once you start thinking about it, it's just overwhelming. Every single thing, everything you're wearing, touching, everything you can see has been manufactured somewhere. But for most of us, how those things arrive in the world, it's completely invisible. We don't really see it. We see bits of it. We see trucks whizzing around. You see the outside of a factory. Some of you may work in manufacturing. In fact, I should do a quick check. How many of you work in manufacturing? Perfect, right. The rest of you will have, unbeknownst to you, will have had some connection with it, but it's pretty remote. It's just sitting there. As someone said, it's a bit like the sewage system. We know it's there, we're grateful for it, and we don't really notice it until it goes wrong. And just like the sewage system when it goes wrong, manufacturing has been going a bit wrong. And this is what the book's about. It's not a doom-laden book, it's a very upbeat book, making the point that we've built this incredible system around the world to do incredible things. So you now, some of you may be doing this, get your phones out and maybe buying something or doing some transaction on your phone. Incredible cascade of events that's going on in the background to ensure that the thing you want will be with you tomorrow morning. You can go into any supermarket and it will be well stocked. You can go to Amazon and buy a camera that tracks you around the room. All of these things just happening. It is mind-boggling when you think how many things are available to us with so little effort on our part. The problem is, well, there are three main problems with what's going on at the moment. And I'll illustrate this with a few stories. Number one, it's very clever how it works. It's staggeringly clever how this system works. It's a bit fragile. That's putting it mildly. And we'll come to this, but examples of things such as what happened during COVID when we were suddenly confronted by empty shelves, or Amazon saying it won't be 24 hours, it'll be a couple of days or a couple of weeks, and then a couple of months, and then we don't know when we can get this to you. But far more seriously, look what happened in the hospitals. We suddenly didn't even have the basic things of rubber gloves and face masks, as well as more important things, or even more complicated things, such as medical ventilators. We just didn't have them. There weren't any for buying. So what do? Because the manufacturing system couldn't react quickly enough to deal with this. It's quite fragile. Secondly, it's not very fair. There are fantastic jobs in manufacturing. And every year our institute, I'm not going to sell the institute, but we deliver around 100 graduates to the world who've studied manufacturing engineering, the very practical aspects of manufacturing engineering. There are wonderful jobs they go on to do, and they have a fantastic career. I've been doing this for nearly 60 years. It's wonderful. But there are also some absolutely appalling jobs in manufacturing that we don't even see. We don't even know what's happening. And so there's that bit to it. It's not very fair, but it's not visible at all. And the third bit, which I'm probably going to I am going to major on, is the sustainability side of it. It's dealing with, it's a wonderful, spoiler alert, this is the end of it, Maslow's hierarchy of needs. We've got to deal with all the basics. People need shelter, people need food, people need heating, they need that stuff. And then when you've got all those sorted, you can move up and, self-actualization and being a more confident, happier person, all those good things. Got to get the basics right. Manufacturing has delivered the basics in theory, for almost everybody on the planet. But it's not really working. And in a wonderfully ironic twist, the very act of producing all these things we need is actually destroying the planet. So that's a quick summary of a rather doom-laden message. I'm going to be much more upbeat once we get into the talk, though. So we've got about 35 minutes of me waffling away with some videos to break up the tedium. I also have something, I don't have a magician's cape to pull off some hidden things here, so it's this rather untidy mess here of my scarf. Underneath there is something very important that I'm going to show you, and I almost guarantee that when I show you one of the things under there, many of you will go, okay? Just warning you about that. Online, it'll be a little harder, but I'll see if I can make it work too. Right. Let's see if the technology is working. I've been standing still for too long. Right. Try this again. Flash blue. Now it'll start creepily following me around. Ooh, very good. Right. I just need this. So I have this idiotically long job title. And when I got this job and had all those things written up there, I have wonderful colleagues. And just to keep me grounded, they put a little graph on the door of my office. And it was a graph of 2 axes. Along the horizontal axis, it said length of job title. And on the vertical axis, it said grip on reality. And you can imagine which way the curve went. Anyway, so hands up, please, if you know who Dr. John C. Taylor is. That's okay, I have to, just in case I make anything wrong here, one kind person who helped with the research for this book is actually sitting here in the room as Dr. Lizzie Martin there. So you should know who Dr. John C. Taylor is, and you do. He invented this. So this is something that all of you will have in your house, I almost guarantee it, and most of you, nearly all of you, will use it every single day. It is a kettle controller. It is the device which switches off your kettle when the water boils. And so it has a number of bimetallic devices. Main one is here. This is the steam switch, which says when steam passes over it, the bimetallic thing doesn't just bend slowly, it goes snap and switches off. This is used every day, plural, billions of times. It has to work perfectly every single time. And Dr. John C. Taylor not only invented this, he built the machines that make it. They're still making them on the Isle of Man and in Guangzhou in China. And as a result of his incredible success in business, he was able to make a donation to the University of Cambridge to create the Dr. John C. Taylor Professor of Innovation, and by a series of accidents and mistaken identity, I got the job. But can I just pass this to you to pass around, please, and have a little fiddle with it? Yes, so that's that, the talk. To try and ground things, what we often do with our students and the companies we work with is talk about consumer electronics a lot, because everybody uses consumer electronics, and it's very tempting to launch into a story about the manufacturing of the iPhone. Everybody likes a story about phones and the good sides to it, and you can find all sorts of things going on there. But I would rather start with a slightly different product, which is differently impressive, but illustrates the same point. And if we just look at that as a product, okay? Just so people go, well, it's not even a manufactured product. It's just, some trees and you've squished them and, there you go. The truth is, when I started trying to make this point about everything being manufactured, I realized I was setting myself up for a fall because I didn't know that much. There's this lovely concept called the illusion of explanatory depth. We like to believe we know a lot of stuff, and I'm sure many people in this room do know an awful lot of stuff. We don't perhaps know quite as much as we think we do. Once we start trying to explain it, it falls down very quickly. And I absolutely suffered majorly from that. So I thought, start off with something simple. So there you go, loo roll. I knew it started with a tree. And I thought, well, I looked up trees and where they come from for loo paper. And apparently, because we need the combined functions of softness and strength, you need different types of trees to provide cellulose fibers with different material properties. The soft ones come from warm climates, such as South America. The stronger ones come from Scandinavia. And I thought, wow, how long does it take to grow a tree? I have no idea. Apparently, minimum 40 years. There's a 40-year production cycle, right? And then you go, well, I just vague image of people, Monty Python, lumberjack, chopping things down. So I looked at how trees are harvested now. So this is a tree harvesting machine in Sweden. And it doesn't look very impressive, just a big tractor with a thing on. Look what it's going to do. So it has a chainsaw in that grippy thing there, technical term, and it chops it down. And you go, well, that's not very interesting. And then, because of all the electronics and clever thing going on there, it says, right, we'll do that, ship off the little branches, chop that off. That's going to be one for timber frame housing. That's another one. Get all that off. That's the same length, perfectly done. A bit thinner now, so it needs to be shorter for shorter bits of wood. Top bits are probably going to be for the pallets or something. And then we're getting to the tiny shreddy bits at the end. That's probably going to be turned into wood chip, maybe to wood pulp, right? Just amazing. And that's just one start of one bit of one process. So I got to the point where I went, right, I know that there are trees involved, unless it's recycled paper or bamboo, but still, that's grass, I guess, not tree. And between those 2 points, I was a bit hazy. I knew there was a rolling mill involved. I didn't know anything else. So I looked into it, and you go, well, those trees are transported to some kind of wood mill where they'll chop it up, and some of it will be made into chips of wood like that. Some of it will be made into flat pack furniture, MDF. Some will be sent off to a paper mill, pulp mill, which could be in a completely different country. And there you do all this mechanical and chemical and heat treatment to extract the cellulose fibers. You then take all the water out so you can transport it more cheaply on a ship. You then take it to another place, a paper mill, where you put the water back in again and smash it all up again and do all the spraying onto reels. And I don't have a video of a loo roll factory, but a paper mill, but I have one of a general paper mill, and here it is. So 4 short videos. What you'll see is this one is what it looks like when they add the water back in again. This is, so from right in that perspective distance over there, when I click the video, you'll see it panned all the way around. It's one massive machine. It's like a paper mill is kind of like a machine wrapped in a building. They're just enormous machines. And I'll walk along in a minute, and you can see all the stuff going on hidden away behind these glass doors. And out the other end comes these giant reels, which are then, if this were toilet paper, would then be chopped up into smaller reels. This is actually newsprint. So paper over there. Huge amounts of energy, incredible sophistication to get the paper at the right quality. So it goes from that, then it'll be transported again to some kind of distribution center, where it'll then be collated for different supermarkets or different routes to market. It'll then be shipped off in more trucks and finally end up in a supermarket. So all of that, all of the megawatts of energy, all the hundreds, well, in many cases, thousands of miles of transport, vast amounts of water put in, taken out, put in, taken out, all of that activity over decades to get to what you want for something as simple and mundane as a roll of loo paper. So it's when you start to think about manufacturing, if it's that complicated for something superficially simple as a loo roll, what's it like for everything else? And I realized I didn't know. I suspect many of us don't have a full picture of all of that as well. So just to give you the executive summary of the book as a teaser, but this is just a talk I would give anyway. In fact, the book is the result of giving talks. It's the other way around to perhaps normal. And so it starts off with the making bit. Now, again, very tempting to go charging into Rolls-Royce or Jaguar Land Rover and go, oh, let's look at the way in which factories that make real things work. And I thought, no, I mustn't do that. Start off with something that just makes it very clear to an audience. You know, this is the, I'm making the terms right here, the Royal Literary and Scientific Institution. This book is aimed at everybody who may have had no background in science at all. And so I wanted to start with examples that are hopefully relatable. I love cake, right? And I like baking. So I thought, as a theme all the way through this, we'll illustrate the different types of making, which is basically what happens in a factory through cake. Bear with me, I'm quite hungry. So factories, the way they, I mean, we can have a long, in fact, I have a colleague just down the road, Mike Lewis, who would give a much better and more detailed presentation of what happens within factories and what happens in logistics. But for me, starting off very simple, this is my kitchen. It is one type of factory. It's a factory known as a job shop. So it can deal with something very simple. It can do very high variety. It's a set of standard tools that can be, in theory, used to make absolutely anything. It is terrible at volume. It's low volume production. I can make one tray bake of brownies up top there. I could make maybe 2, and then I'd get out of control. I couldn't make 10. It would just be a disaster. I certainly couldn't make 100. So that's what a job shop is. It's about specialized things done in very, very high variety, low volume. What if I did want to make hundreds or maybe thousands? Well, then you move to batch production. And in Cambridge, there's a lovely bakery called Fitzbilly's, and they're famous for their Chelsea buns. So I joined a shift at 3 o'clock in the morning to go along there. And there I met Sam on the right and Tony on the left, and they are making batches of hundreds of Chelsea buns. So they do it literally. We're going to make 100 of these, and then they've done that, and they shift on to the next thing. So slightly higher volumes, and with a degree of variety in there still as well. And I just love this is Jean, who does the chopping, so he's got to make exactly 40 Chelsea buns, because each tray, each full-size tray, is 40 buns. So you'll see him chopping. There's no measuring, almost this goes along, quite high, and you see 40 Chelsea buns, the wheels there, the end bit there, this one. So skilled, right to the end, and the tiniest bit of waste at the end there, immensely satisfying. So that's hundreds to thousands, but what if you might want to make hundreds of thousands of a cake? So basically what Sam and Tony have got here is a very big kitchen with equipment that looks not dissimilar to what's in any of our kitchens, but it's just bigger and maybe more of them. But once you get to things like this, so these are produced in batches, it's mass production. They do 250,000 a day. And for that, you can't have Jean chopping away like that. You can't have, well, you could have lots and lots of people working on it, but we don't. You go to automation. You standardize the process, you reduce the variety, and you say, we're going to produce 250,000 cherry bakewells. Okay? And ironically, though, despite the machines being absolutely fantastic in a high-volume food factory, or any high-volume factory, I love the fact that the last bit of putting the cherry on top still has to be done by hand, which is rather lovely. But there's another type, so that's job shop, high variety, infinite variety in theory, very low volume. Batch production, half and half. Mass production, high volume, low variety. There's another type, which is very, very low variety. They only make one thing, but they make it in huge quantities. And that is what we call continuous manufacturing. So this is glass, paper, all these things, and sugar. So again, as in the book, go and visit this plant here, which is one of the most environmentally friendly, doesn't look it with all that steam coming out, one of the most environmentally friendly factories in the UK. And basically, trucks come in, loaded up with sugar beet, which is where most of our sugar comes from the UK, and goes through a single process right the way through and ends up filling up those silos there with thousands of tons of sugar. It's one process, the application of heat, chemicals, mechanical processing in one flow through. That's continuous manufacturing. So there you go. Those are the basic 4 types of factory. And every single one of them, of all 4 types, is doing the same thing. You are taking inputs, doing some kind of process, and producing higher value outputs. That's it. And in the middle, those processes are people following a recipe, a method, with some kind of materials and some kind of machines. Every factory is doing exactly that and fits into one of those 4 categories there. So that's the making bit. But we do an awful lot of moving stuff around. It is incredible how, to make this manufacturing system work, how much effort has to be put in to getting the right thing in the right place at the right time. It is mind-bogglingly crazy in many ways. And so to illustrate this, I went to our colleague, Dr. Mukesh Kumar, and I said, can you give me an example of a manufactured product that has an interesting supply chain? And he went, sure. I went, I clearly have asked the wrong question. And he said, no, no, bear with me, because I went, really? But when you have a field, and you have field to fork, I mean, that's not very complicated. And he goes, oh, Tim, you know nothing. And he showed me, that's the simplified version of the lettuce supply chain. It's a leaf. You take it out of the ground and you wash it and you sell it. How does it need a complicated supply chain? But you do. You have all of these massive farms and in many cases greenhouses scattered across the country or overseas. This is the UK supply of lettuce, including Spain, which we buy a lot of. You then have to have all of the cooling facilities to keep it fresh and do all the washing and everything. Then there has to be all of the packaging and making sure it's in the right place. It goes to a distribution center. Then it's passed on to either direct to the customer, direct to someone else who's going to make salads, or direct to restaurants or whatever else it may be. Even lettuce seems to have a lot of moving and complexity involved in it. That's a one component product. Well, maybe 2 if you include the bag. So that's fine, that's quite complicated, and you go, right, so what if it's that? That's a typical petrol-powered car, it's quite an old one. That has 30,000 components. So a typical car has 30,000 components, and many of them will be made in different factories in different places. All of those have to be brought together to make a car. Now, some of you may be going, that's old-fashioned, you know, electric cars much simpler. Yes, they are much simpler. They only have typically 15,000 components. Okay, so it's still a lot. They all got to be made in the right place at the right time in an economically viable way. And then you go up a little bit and go, what about that? I mean, I won't embarrass people by saying, well, you may know how many components are in a typical airliner. It's approximately 6 million. Okay, so 6 million individual bits that have to be made at the right cost, at the right quality, at the right time, and put in the right place to do the right thing. And we know what happens when that doesn't work, as was illustrated by what happened to that Boeing aircraft last year when the window flew out because they'd forgotten one of the 6 million components. Luckily, no one was hurt. And it's not just little components. You're probably thinking, he's exaggerating for effect. It's just, shipping some rivets around is not that complicated. That's true. They've got to be the right rivets. But actually, the components they're shipping around sometimes are like this. Some of this is build an Airbus A380. It's the same process for other aircraft. Massive, they don't just make little bits in different places. They make very big bits in different places. That's what you believe them. I happily share this video on YouTube. It's the A380 in 7 minutes. We don't have 7 minutes to watch it now, but it's just So when you start to map out all the companies involved in making those 30,000 components or those 6 million components, just working out who's involved and how they're connected actually gets quite complicated. And companies lose track. They know who their suppliers are, clearly, and they have a pretty good idea of who their suppliers are, and they might have a fairly good idea of who their suppliers are, but carry on right the way down the network. Many firms don't know who's at the far end of a supply chain. So when a company says we're absolutely sure that no child labor in the Congo was used to extract the cobalt that's in this particular phone, I don't think they can ever say that with 100% confidence. They'll do a good job and really try to not do it, but it's so complicated, bad things can happen sometimes, unintentionally. So we have another colleague, Alexandra Brintrup, and she's been applying AI to get all of this messy data to say, can we draw a picture of what's going on? Not just so you can have amazing pictures of the current car company and an aerospace company to say, wow, it's complicated, but to predict what might happen if one of those nodes, each node is a company, fails. What happens if there's a fire in the third tier rivet anodizing company for Airbus? One of those companies has a wobble because someone goes on strike or there's a fire or someone gets ill. What's going to be the effect on the rest of the system? And that's what she's trying to do, is to say, well, can we predict what would happen? So maybe if it's going to be catastrophic, we can maybe have some backup suppliers there. So all of this moving is extraordinary, but it's not, this makes it a bit sort of sterile. It just goes, oh, it's dots, it's connections, it's maths, and it is. But the truth is, it's this. It is the physical moving around of things. So here's a typical container port. And again, just remind yourself of the sense of scale there. That's a shipping container. So it's 40 foot long, 10 foot high and wide. All of this is happening 24 hours a day, 7 days a week throughout the year. All of these things are moving around. So they're not just two dots and a line drawn between them. There is stuff moving around. That ship can carry 20,000 containers. And every single one of them will have multiple products in. And then I went off to Felixstowe Docks and climbed one of the cranes and just looked at that and went, whoa. I struggled to find my car in a multi-story car park. They've got 150,000 containers there. They've got to know what's inside every single one, where it's come from, where it's going to, who's collecting it, when they're collecting it. Some of them are temperature controlled. Some will have very dangerous things in them. Some will have very safe things in them. Everything has to be known. So it's a very tangible process. And then it's not just boxes moving around. The boxes are unpacked and you end up with these. I mean, how big that Amazon warehouse is. There's so much going on and very, very few people. There's lots of machines moving stuff around. And if you shop at Ocado, it will have gone through one of these incredible three-dimensional warehouses. So in a warehouse like this, all the goods are underneath. And the people, the bag packers, are behind those blue things up there. And these robots are whizzing along completely autonomously, working out where a particular toothbrush or toilet roll is, finding it, grabbing it, picking it up, carrying it over to where it's needed. All of this is now happening automatically. So what looks like a simple process of dots and lines, and it's very complicated, is real things moving around in real time. It's absolutely extraordinary that it works at all. And then there's us. We come into this to really make it complicated. Life used to be simple. Before the Industrial Revolution, and I'm not one of those, oh, it would be great if we went back to those days before the Industrial Revolution, or we could. Life expectancy, 35, not so good. So there were lots of bad things. But one of the things that was simple was my shoes are broken, I can't repair them, I go to a person who will make me some new shoes, and I will give them money or exchange a goat or whatever for them. And then factories came along and we developed the idea of mass production, and we produced far more than was needed. Then we had to create the idea of not sating appetites and needs, but creating wants. And again, I do like cakes and chocolate, and you used to buy, I shouldn't go on like this, but I just find it incredible. There's a Lindt bunny, right? Surely there needs to be only one type of Lindt bunny. No, of course not. There have to be multiple types of Lindt bunny, right? And then just chocolate. Well, Kit Kats, these used to be sounding quite old and grumpy here. They just used to be Kit Kats, and now there's hundreds of variety of Kit Kats, and just dairy milk has gone anyway. The point is, demand has to be created, and we have to keep sating this insatiable demand and fickleness that we all have. And that was just one aisle in a French supermarket, and I just stopped and went, and that's just basic chocolate in all its different flavors. And you go, whoa, do we need? Well, we do, apparently. So that all of this is very hard to manufacture, because if you're guessing what lots and lots of people want, you've got to produce and just hope people buy it. And yes, there are very sophisticated tools for working out how we can judge what a particular person might want. That's all great. The truth is, a lot gets wasted. We change our minds. They've made it and no one wants it. So wouldn't it be great if there was a technology that would just build you exactly what you want? Well, in a way, a slight hint to the future here, there's a production technology which has some of the characteristics of not mass production, not customization, a combination. You can do mass customization. Every single product made can be unique for a unique customer. And the example is 3D printing. You'll go, oh yeah, 3D printing, we've seen how it can make small things. But in theory, do this. You build a car. Rather than using standard products which are 8 different colors, different engines in, and say, it's a different car, then people don't buy it. Make exactly the car the customer wants. Now, any engineers in the world will be looking at this and going, I wouldn't drive that because it's very outdoors. Showing the possible future, the idea of mass customization. That machine could build anything, any shape that fits in that box. That was a test of the enough of that. Now, those are the basics. Stuff happens in factories, stuff moves between factories and the consumer, and then the consumers need to be sated. Last few bits here, a big problem for manufacturing is that what we really want as factory managers is things to remain stable, not to change. And what we'd really like is everybody to just say, I would like one, and I'd like it to be blue, and I'd like it to be like this. And they go, great. How many do you want? 10. Well, we're going to make 10 every day because that's all that's needed. You can't do that. So that's one type of change that has to be dealt with. Customers want different things. But then we have technology comes along and changes things. Technology, we've had this for a few years, and basically that's the Benz tricycle. And without being unkind to automotive engineers, it's basically the same technology 100 years later. I mean, it's still squirting petrol vapor into a cylinder and exploding it and firing a piston. It's with some enhancements, I'll definitely give you that. But to make that work, we needed to work out how to get lots and lots of oil to convert it into gasoline or to petrol. We had to then do all the processing to get it done at scale. And we had to cope with the fact that it was leading to lots of pollution. But we kind of got to a point where the car industry wasn't really changing. That's just how it was. And then along comes, I'm very torn about talking about Elon Musk at the moment, but ignore the person, just think of the idea, coming up with a high-performance electric car, which, by the way, just to clarify, Elon Musk did not start Tesla. The company had started, he joined and did some extraordinary things, but he did not found Tesla. But it is remarkable what they've done because they kick-started massive change in the car industry. Mass-scale battery factories which do this incredible process of producing millions of individual batteries that are needed in electric cars. And then making sure that, that removes the need for petrol coming out the tailpipe, but you still need to have charging infrastructure and you need to have renewable sources of energy, otherwise you're just putting the pollution somewhere else. But there's another bit of change. Now to do this, I'm being very careful and not making any comments about age, but do any of you remember using a phone like this? I'm amongst friends. Can I just pass this around for nostalgia's sake? Right, we're going to move forward fairly swiftly through the decades. And then, so this was great. Manufacturers went, great, mobile phones. Michael Douglas had one of those in Wall Street. Love it, let's make some of those. And customers went, could you make it a bit smaller? I went, oh, right, so the factories had to be rebuilt to make smaller phones like this one, which some of you may remember, which has this utterly pointless rubber pretend aerial there, and a wonderfully, a visceral approach to ending a phone call. No tapping a red button on a glass screen. No. If you hung up, you knew you were hanging up. Isn't that fantastic? really a physical experience. And then people went, we like that, could you make it smaller? And the engineers again went, oh, we just built the factory to make those. And then we came up with the, see, that's the R phone, right? Yes, you still use it. Fantastic. So this, oh, that's wonderful. So this, the Nokia 3310, one of the most successful phones of all time. What was the game you used to play on it? Snake. Fantastic. So again, just that, engineers went, great, you want it smaller? We've made it smaller. And then I love this, they went, yeah, it's very nice, but could you make it smaller? And they went, oh, all right, we'll make it smaller. So this phone, it's so tiny. Is it? This is another Nokia, actually, this one. I'm just going to do a quick test. I'm going to put the mic down for people online. So if you want to replace the battery in an iPhone, if you're very, very skilled, it's going to take you, an hour or so. If you're not skilled like me, it'll take you a day. I'm now going to do a demonstration of how long it took to replace the battery on a Nokia. 1, 2, right. So simple, so good. Right, I know there are engineers in the room. Would you mind reassembling this one? I won't be judging you. The point is, it got smaller and smaller and smaller, and then all the factories are set up to make these tiny phones. And then what did we say? Could we please have the internet on our phones? And then the phones got bigger and bigger and bigger. So the manufacturers have to keep changing their means of production to deal with the fact that our demands change. Right, so the last couple of bits before we move to Q&A, thank you very much, you've passed the test, is the digital side of it. So the phones, we've moved from analog to digital, and so we've gone from a world where there were sort of computers and there were telephones, and now it's all connected. The world of your smartphone is packed with sensors. Everybody who's got a smartphone with location services turned on in this room is informing Samsung, Apple, Motorola of where they are now and what they're doing. Each app is telling people what's going on. You could say, oh, that's a bit creepy and unpleasant, but actually it means we're designing better products. We can actually get real information on what customers are really doing with products by connecting the physical world of the device with all of the software tools to generate better things. And this is exactly the same in those supply chains I showed you earlier, of Alexandra and Mukesh. Because what they're showing is if you get data all the way along your supply chain, you can see where the risks are. All of these little sensors that are in your phone, these Internet of Things devices, are also replicated in factories and in supply chains and in trucks. They're called industrial Internet of Things sensors, capturing data from every aspect of the manufacturing process to make it better. So the connectivity is huge, and now we can have this amazing world of, what's been called democratized laziness. You don't have to be rich to be lazy. Anybody can just have things delivered to their front door in the next 10 minutes. And we could do a test now and get an avocado delivered here probably in 10 minutes. If anybody wishes to, please do. But I'm not sure it's necessary. And if we then jump forward to the penultimate bit, by using all these digital technologies, by factory managers having digital technologies scattered throughout not only their supply chain, their factories, but the customers being connected, we are all becoming part of the manufacturing system. And the most extreme version of that is when we merge into the product. And so I have lots of aches and pains, and so I always carry with me a healthy supply of I can't even say it, paracetamol, that's easier. With me, somewhere in here, I'm sure I have it. Where is it? Oh no, I have to come without it. Oh, here we go. And here we go, like this, blister packs filled with drugs, as it were. 160,000 tons of paracetamol are produced every year, and it's all exactly the same. It assumes that every single human is exactly the same, and the dose is 2 tablets. But every single one of us is different. Every single one of us has a unique physiology. And so the truth is, for most medicines don't work, certainly don't work for everybody all the time, putting it mildly. So what we're moving to in manufacturing, rather than tons of the same thing and just hoping it works, now that we have genomic data on every single person if they wish to share it, we can develop personalized medicine. And an extreme form of personalized medicine is when you say, well, actually, it will be a factory of one. So here is someone who had leukemia and needed treatment, and so they were put on the CAR-T treatment, which is chimeric antigen receptor T cells. Basically, they take blood cells out of your body, send them off on this complex supply chain to have them processed, to reprogram those cells to attack the cancer, and they re-inject it into your body, and your body then treats the cancer effectively. This is an extraordinary development for the world of manufacturing. We become at the heart of the manufacturing system. We are an integral part of it. And this is a real thing. This is happening now. So this extreme version of the manufacturing world is the consumer is intimately, literally, part of the manufacturing process. So the final part. Well, this is how I end the book, is coming back to survival and saying, we've got to get better at this. So the last 4 minutes, I just want to paint a slightly gloomy picture and then end with a happy picture. I said it's not very resilient, this manufacturing system. I was genuinely shocked, to live in a rich country and be confronted by that. So clearly it's not working very well. You remember this? Yeah, the Ever Given, stuck in the Suez Canal. 10% of global trade goes down there, was stopped. So one person on one ship makes one little adjustment on a lever, 10% of global trade stops. That doesn't sound like resilience. And it caused enormous problems, and it could happen again very easily. And then the bit, as I said, I want to just leave you with the main message is the sustainability side of it. So in terms of sustainability, moving stuff around generates an awful lot of pollution, and by far the worst is road. Okay, and aviation's not very good, shipping not very good, rail remarkably good comparatively. So we can get cleaner electric cars. I remember for me, I was in the world of that middle picture. That's what an electric vehicle was when I was at school, and now it's that. And we see an amazing growth in electric road vehicles, but we're not yet seeing that. Surely we need electric trucks or hydrogen, something to make road transport cleaner. With shipping, that is a zero-emission container ship, but it can carry, I think, 10 containers, whereas a diesel-powered one can carry 20,000. So we're not, work to be done there. And they're always talking about this. Don't replace the diesel engines, but just reduce the need for them by bunging some sails on top. But the shipping industry is incredibly conservative because costs are so tiny, the margins are so tight, it's pretty hard to do anything new. But it is happening. And aviation, getting that thing off the ground is a remarkable achievement, but look at what's coming out the back. So we are moving to experimenting with electric aircraft. And there is the current biggest electric aircraft they can make. I think it can do like 20 minutes in the air or something like that. But you don't make electric aircraft because the lithium-ion batteries would be so heavy it would never get off the ground. But hybrid aircraft, and then maybe in the future some sort of fuel cell-powered zero-emission aircraft is going to be possible. And that's being looked at very seriously. But it takes time. So are there cleaner ways of moving things? Sure. But the last bit is to say, what if we stopped moving stuff around quite so much? What if we said, rather than having stuff made perhaps in China, about 10,000 kilometers away, it would be better. The iPhone, it isn't just it's made in China and shipped here. All of the components have accumulated 250,000 kilometers before it reaches us. This incredible moving things backwards and forwards and having it tested and fertiled and messed around with 250,000 kilometers at least. What if we could do that? And just say, don't do 10,000 kilometers, do 1 kilometer. And we can. We did during COVID. We started going back to local manufacturing. Now again, I'm not very careful what I say here, I was accused of this the other day, I'm not a Trump supporting, bring it all back, must have everything made here. That's just wrong. But there's something about the ability to make things locally, as we saw in makespaces and in local companies repurposing what they did, that shows we can manufacture locally. It's much more sustainable and adds resilience to your economy. So yes, we can reduce the distance we make things, and if we have to move it, we can do it much cleaner. And so what I do in the book is try and end with this upbeat message, going, look, the making thing, we need to think about what we're making. Do we need that thing? In many cases, the answer is yes. Then we look at how has it been made? Where was it made? And if we have to move things, can we move it cleaner? Can we develop better ways of moving stuff around? Can we make things closer to where we are now? Avoid the need for such great distances. So in some situations, making it far away is absolutely sensible. And it's a very rational thing to do, and we should do it. But the way we've let it, so much of it drift away, I think is a bit of a problem. And the last bit is, the third blob there, it's us. I get really aggravated when people will talk about the natural world and our lives, and then this evil thing called industry that is sort of another beast out there that's doing something that we can't control. Well, to some extent it is, but I hope I've shown in this talk is we are all part of it. We can make choices. We click that button. No one forces us to. We have choices that we can make about what we buy, and can think now, with all your phones, all the data we have available to us, we can get a much clearer picture of what's going on with pretty much any product we've made or we choose to buy. And the last bit is, I'm not going to do a great spiel about recycling because I don't think that's the way forward, but thinking about buying things, if possible, if people can afford it, that can have a longer life, that can be reused and passed on to other people. And I'm delighted to see that, I won't pick on anybody from perhaps a younger generation, but if I were to say vinted to people, would most know what that is? This idea of getting your second-hand clothes sold so others can use them. What a great idea. And then there's the repairing. Why is it that we don't seem to be able to repair things? Partly it's because manufacturers say, if you start fiddling around with this, they're so complicated, you're only going to break it. But the right to repair legislation, I think, is really important. Not that it means that we should all individually be able to repair something, but it should be repairable. And that's a slightly different thing. So I was hearing from someone the other day that in France they have the repairability index. When you buy a product, it says, how repairable is this? Which I think is a lovely touch. So that's it. Thank you very much for listening. I hope that's given you a flavor of why I think this is so important, roughly what we cover in the book. We don't just talk about cake, by the way, in the book. There's some other examples as well. But thank you very much for your time and attention, and I'd be very happy to take any questions. Thank you.
Thanks, Tim. That was a wonderful talk. Thank you. I think you've set yourself up, but as everyone wanders out, I think all you're going to hear is, you had a Nokia 3310 in there. That's going to be everyone's highlight, really. But thank you very much. We have got time now for questions. So does anyone in the room have a question for Tim?
Sugar factory. Where was that?
Where?
Yeah, where?
That is, so most of the sugar beet processing happens in East Anglia, and that particular one is in a place called Wissington, near to Downham Market, up near King's Lynn. And it's one of the most environmentally friendly, because the guy who runs it, called Gary, who we write about in the book, who works with us at the moment at our institute, said, this isn't good enough. Sugar beet comes in, we wash the mud and the stones off, and we just chuck them away. It goes to landfill. And then we do all this processing, and it requires huge amounts of heat and energy, and we just vent it off to the world. And at the other end, once you've extracted the sugar, there's loads of low-value products, and some is sold for animal feed, but most of it is just not saleable. He went, what if we create value from everything that's regarded as waste? So he said, right, stones. There's a lot of stones mixed in with the sugar beet when it arrives. We can sell that. That can be hardcore. Okay? We then said the mud. Well, the fens of East Anglia, it's incredibly rich soil. You're washing it off and then just getting rid of it. People will pay money for that in garden centres. So it became a new value stream for the business. They looked at the far end, where you've got the difficult to sell bits of sugar, so the molasses type stuff, and said, there wasn't much demand for that. And so they said, but we need biofuel. And they said, well, why don't we build a bioethanol plant? So when you fill up your car with petrol, it'll say E5 or E10. They've added 5% or 10% biofuel to it. That's made from the waste, some of it is made from the waste product of a sugar beet factory. And the bit that really amuses me was all of the heat they were generating and CO2 venting it to the atmosphere. They said, what can we use that for? Greenhouses. So they partnered with another company and they built acres of greenhouses and started ripening tomatoes throughout the year. Brilliant idea. Only problem was economics and global trade meant that the price of Spanish tomatoes was still lower. It wasn't economically viable to keep selling them. And someone went, what's a plant that has a very high value add, it sells for quite a lot of money, that requires a lot of heat and a greenhouse? Cannabis. So that plant, sorry, medicinal cannabis, that is now Europe's biggest, next to it is Europe's biggest greenhouse. I mean, it's massive for medicinal cannabis. And it's just, the idea was, don't waste anything. There is no waste. It's just a product for someone else, even if it's heat and CO2. Please. Oh, that slide? Yep. So I'm not an expert on cell therapy. That was merely an example of a patient who had become cancer-free by going through, her cancer was treated with gene therapy. So it's a very, yeah. Yeah. So you're asking the difference between a cell therapy and a gene therapy. I'm not I would have to ask my much more intelligent wife about the differences there. Right. Oh, I see. Yeah. I take your point. Sorry, I misunderstood the question. Yes, absolutely. It is for very, very specific types of cancer. This is for blood cancers. It's only for that. I'm afraid it's not a general treatment. Sorry. Anything online?
Yeah.
Several questions here online. So, second.
Roughly in this direction. So it was brilliant for a while, then it lost interest.
So, Tim, this question is from Greg Spiro, or Greg Spiro.
Hi, Greg.
Tim, for most of my life, there has been a somewhat snobbish attitude to the manufacturing in the UK compared to services. Do you think there's still an attitude problem, or will a focus on high-end enabled manufacturing to be properly respected as a career?
Greg, was it?
Greg.
Yeah. Greg, thank you very much for that excellent question. I completely agree. There has been a problem with the image of manufacturing, and there's a horrible quote I put at the end of the book, which was from a colleague who's roughly the same age as me, and we were standing at an event in Coventry and saying, "God, isn't this great? There's all this manufacturing around here, and it's regenerating the economy, and it's wonderful." And he was talking about his childhood, and I was saying, "Gosh, I grew up in Norfolk. I remember we never went to a factory. It just wasn't a thing we would be taken to." He described growing up in the West Midlands that he was taken by his school to visit factories. I thought, "Oh, well, that's great." He went, "Well, no, because the reason the teachers took us to the factories was to say, if you don't work hard at school, you'll end up here." So, Greg, you're absolutely right. That's the kind of image problem we've got. And that was one of the abiding reasons for giving up the weekends and my family being very tolerant of me giving up holidays to write this book, was to try and, in a very modest way, start to redress that negative image of manufacturing. It's not uniform, and there's sort of this slightly weird thing we noticed during COVID of some of our excellent politicians and civil servants just not knowing enough about manufacturing to make perhaps the most appropriate decision. The assumption was, haven't got ventilators, well, here's the government credit card, please clear off around the world and buy some ventilators. Well, it's a pandemic. It's everywhere. There were no ventilators. Rushed back, and I think at that time the output of ventilators in the UK was 5 per day. We had something like 8,000 in total, and they estimated we might need around 30, 40,000 ventilators. And they went, make more ventilators. You can't just suddenly make more. It's really, really difficult to do that. And they said, well, we should get more people involved. And there's this idea of what's called the industrial commons. Back in the days of the Industrial Revolution, there was lots and lots of manufacturing going on. So if you started up a new business to do some manufacturing, there would be people you could recruit who knew about manufacturing. There were suppliers who could supply you with the bits you needed, and all of those things were there. And then we sent a lot of manufacturing overseas, and so all of those commons, all the people with the skills and the suppliers, either moved as well or just withered away. And so we stopped seeing manufacturing, and the bits we did see, to Greg's point, were very negative. We just saw, closed down factories. We just saw the tail end of industrial production. And why would anybody want to go into a job in an industry that seems to be clearly declining? Ironically, whoosh over here, and we've got the likes of Rolls-Royce, Jaguar Land Rover, AstraZeneca, Unilever, doing wonderful high-end production. I mean, think how many, which the majority of all motorsport companies, particularly Formula One, make their cars in the UK. We are very, very good at some things. Automotively, some of the Japanese production plants in the UK are more efficient than the parent company's plants in Japan. We can do this. It is something quite remarkable. Sorry, got carried away.
So the second question is quite pertinent. It's from Charity Grenville. If you could advise a government keen on investing on new industry, what type of manufacturing would you recommend the UK concentrate on?
So the reason I'm pausing is I'm having flashbacks of PTSD, because on Sunday, I got an email saying, could you appear on the Today programme? I went, oh, very tempting to skip. No, can't possibly do that. I thought, no, I've got to do it. So sleepless night, go on to sitting in my little bedroom and get a call, and it's the Today programme. And then I suddenly realised there's now millions of people are listening to what I'm going to say next. And the wonderful, from my oversharing here, the wonderful presenter clearly thought when it said Institute for Manufacturing that perhaps I was from a lobbying organisation. And he got the book in front of him, and he said, no, he's just some nerdy academic who's enthusiastic. And so he asked, was it Charity who was asking the question? So Charity, yes, exactly the same question. And he ended the interview with, well, that's all very interesting, Professor Minshall, so which industry should we focus on? I thought, there's like 5 million people. I'm not in the government, so I thought I could just say, oh, it's not for me to say. But I just thought, I've got to say something positive. And so I went for healthcare. And because I genuinely believe that it is one of our great strengths in this country. We have unbelievably good science, unbelievably good research on the life sciences. We are world leading in that. And the modern treatments, the personalized medicine treatments, mean that we have to be able to manufacture these things in the country as well. And there's lots of evidence about not only the drugs, but about the medical devices and the operation of hospitals that requires manufactured products that you can customize locally for individual patients. I could go on for hours about that. I better stop there.
Okay, so if you've got time, one more.
I have.
It's an observation. Graham Howe. Yeah, so not so much a question, but an observation, as it never ceases to amaze me how much we actually manufacture here in the UK. We need to improve how we promote manufacturing here, particularly through and with the media. So thank you for writing the book, Tim.
Oh, thank you for that observation. What a lovely way to end. And that is, without sounding, I don't know what, that genuinely was the reason for writing the book. Just to try and it's not a lobbying thing, it's not an overselling thing, it's just an explanation thing. This is how it is. And there are fantastic examples of manufacturing. And the more, last comment, I promise, just raising the visibility of how manufacturing works, the visibility of how the things that come into our life are made, I think just a little more knowledge about that will help us all make slightly better decisions. It's not a miracle thing. There's no magic in that book that says, do this, the world will be better. It's nudging us towards, hopefully, a slightly more sustainable, equitable, and resilient world. I better stop there.
Thanks, Tim. Sorry, have you got one more question?
Please.
I was wondering, just looking at what you said about, the duration of products, are there some traditional areas of manufacturing which are going to face a demand deficit going forward? I mean, I was thinking about showed motor cars there. My father was a general practitioner in the days that general practitioners used to go out and see patients and do nights. So he needed a reliable car.
Yep.
That meant he actually changed his car every 2 years.
Right.
I've got a BMW down there, which is 9 years old and runs like new. And I think, you know, there are things like in your house and things like that, where there just is going to be, provided people are willing to put up with yesterday's, you know, there will be a demand deficit.
It's an excellent point. And so, sorry to keep saying in the book, but in the book, this issue of obsolescence and, you know, the model that I find intellectually rather upsetting, that we have to keep making things. You know, we've got to have more and more and more things. We must keep buying more things to make the economy work. But you just go, yes, but we it's heading towards exponential. You get to a point where it doesn't work anymore. And so a lot of the problems we're creating seem to assume that we're going to go we need to find a way to make different things for different markets. We'll push products into countries that are rapidly moving up from low to middle income to higher income. And that's fine, we'll just sell more stuff there. But at some point, there's a limit. So I am pessimistic in some ways about how we deal with that. But I'm very optimistic around your nine-year-old BMW. You know, people willing to say, I can keep this. Okay, I have to mention Tesla once more. This is from someone, though, who does own a Tesla. I don't. My colleague owns a Tesla. And yes, he has stuck a sticker on the back of it which says, I bought this before Elon went mad. I'm not political statement, I'm just saying what the sticker said. And he said it's extraordinary because he bought it several years ago, and since then, it's got better. Because you get sent up. So the features that you had to pay extra for, they've said, we'll just give them away for free now. So suddenly, the brakes got better. The vision system got better. And he went, well, that's quite clever. So you want to keep the product because you don't need to buy the new one. It comes with it. So I think there's going to be a change in the way we think about that. The example of cars is particularly interesting as we look at the figures for the current generation and the proportion who have driving licenses. It's much lower than it was in our day, much lower. And so the idea then that why are we going through this, cars being a great example, you want to have a car to get your freedom to drive? Well, you don't need to because the systems are out there to allow us to just grab an Uber when we need one, rather than own car or very expensive taxi. There's something in the middle now. So I think this whole dynamic of production and consumption is changing, and there's this idea of, it's a terrible word, servitization or product service systems. It's not about the product that you're buying the use of it, as beautifully illustrated by Rolls-Royce. You know, very few people buy a jet engine. What they do is they say, I have 6 aircraft and I want them flying for N thousand hours a year. You, Rolls-Royce, make sure that all my planes have enough power to do that. I don't ever own the engine. I pay you for a number of thousands of hours. So it changes the way you think about the product. And that means that Rolls-Royce wants to make the engines as reliable as possible because they don't want to be fixing them after every flight. There's so much in your question, but thank you very much for that.
Well, thanks, Tim. That was excellent. Thank you. We've got a few minutes now. If anyone wants to come up and have a little look at Tim's book, have a chat with Tim, we will move to that. But yeah, I think on behalf of all of us, I'd like to say thank you. So yeah, thanks to Tim.
Thank you very much. Thank you. Thank you online too.